Here's the bullet problem. It says when a bullet is fired into a bank of sand, its retardation, negative acceleration, is equal to the square root of its velocity that it had when it entered the sand. For how long will it travel if its velocity on entering the sand is 100 feet per second? Round to the nearest second. Let's just kind of get a visual of what this is saying so we understand what we're looking for. So here's our sand bank, and we've got our bullet right there, and it's going into the sand bank. And so when it hits the sand bank right here, it actually kind of starts to slow down, right? It slows down until it finally stops. And when it says retardation, that means negative acceleration, and that's exactly what happens. Your bullet is slowing down. Its acceleration slows down as it hits the sand and gets that resistance. And so the question is giving us all sorts of information about its velocity and its acceleration, and it wants to know how long will the bullet travel. It's going to travel for 12 seconds, 2 seconds, what do you think about that? So now that we have that down, we have to go ahead and take this information and write some equations. So first of all, it says that the negative acceleration right here, the negative acceleration, I'm going to write that right now, the negative acceleration is equal to the square root of its velocity, Okay, and I'm going to go ahead and rewrite this so that this helps me. And just a reminder, acceleration is the derivative of velocity. So I'm actually going to write this as negative v prime of t equals the square root of velocity. Now, even more so, we kind of learned on this last video that we can rewrite this notation right here, and I'm going to rewrite it as a negative dv dt. That's basically just saying the derivative of velocity, which we know to be acceleration. All right, and I'm going to, for simple sake, I'm just going to get rid of that v of t, and we're just going to write this at the square root of velocity. Now, folks, from this point out, I'm just going to start with this equation right here, but I did want to show you how we got there. All right, next thing that we're going to do is we're going to do a separable differential equation. We're going to solve this. And what I'm going to start with is I'm going to multiply by dt on this side, and I'm going to multiply by dt on this side. So here my dt's cancel, and I'm left with a negative dv is equal to the square root of v dt. Next thing I'm going to do is I'm going to divide by the square root of v. Okay, this cancels, and I'm just going to be left with on the right side a 1 dt. And then on the left side I have a negative 1 over square root of v. Okay, and then that's going to be, I'm going to just pull that dv out. So I hope you see that this is going to be a negative 1 over root v. See that right here, how that's a match? And then I pulled that dv out. Now, just for the sake of integration, making it easier, I'm going to just multiply by negative 1 on both sides. You don't have to do this, but I'm going to. And so that negative 1 is going to kind of cancel right here, and I'm just going to be left with a 1 over root v is dv is equal to a negative 1 dt. And that was, just, I like it. It looks better to me. Next thing we're going to do is we're going to integrate both sides. And so I can rewrite this integral as v to the negative 1/2. And we already know that the integral of negative 1 dt is just going to be a negative t. I'm going to put the plus c here on this side. Now, integrating this, I am going to add 2 over 2 to this. So that's going to give me v to the 1/2. And then I can divide by 1/2, but we know that that's the same thing as multiplying by 2. So folks, all I've done here is just integrate. There we are. And I'm going to go ahead and rewrite this as 2 the square root of v equals negative t plus c. And we now have to solve for c, and we've yet to do this, but we have enough information in this problem to do so. So for example, I know that the velocity on entering the sand is 100 feet per second. And we're going to assume that when the bullet hits the sand, okay, we're going to let that be time equals 0. And so when the bullet hits the sand, our velocity was equal to 100. See that right here. So I know I'm going to have, let me bring this back up here, 2 times the square root of 100, because that's my velocity, I'm plugging right into there, is equal to negative t, which is a negative 0, or which is just 0 plus c. So you put in 0 into that. And so now I know this is going to be 2 times 10, which is going to be 20 equals c. So my equation is 2 root v equals a negative t plus 20. All right, we have our last thing, and that is we want to figure out how long it will travel. How long it will travel. Well, we are trying to figure out when the bullet stops, how long it's going to travel until it stops. So we want to know what the time is when my velocity is 0. This means when it stops, right? Velocity is 0 means it stops. So I'm trying to find how long it's traveling until the velocity is 0, meaning that the bullet stopped. So let's go ahead and plug 0 in for v. So I'm going to have 2 square root of 0 equals negative t, so that's what we're searching for, plus 20. Well, this becomes 0 equals negative t plus 20. Subtract 20 to the other side, I get a negative 20 equals negative t. Multiply by negative 1 and I get 20 seconds equals t. And that's our answer, that the bullet has traveled 20 seconds until its velocity was 0. Sweet. I do want to do one more of these problems. If you feel like you understand this and you want to try this on your own, feel free to do that and then just scroll through to see if you got the right answer. All right, so same exact problem. We're told that it's retardation, the acceleration, which I call that dv dt. It's acceleration right there, that's acceleration, is equal to the negative square root of velocity. I'm going to multiply by dt on both sides. That gives me a dv equals negative root v dt. See how I multiplied by dt? Bam, bam. Okay, next step is I'm going to divide by a root v. Okay, and so I'm going to rewrite this on this side as 1 over root v dv equals a negative dt. All right, now I integrate both sides here. The integral of a negative dt is going to give me a negative t plus c. Here I can rewrite this as a v to the negative 1/2 dv. Integrate that by adding 2 over 2, which gives me v to the 1/2. Then I divide by 1/2, which is the same thing as multiplying by 2. It's reciprocal. There we go. All right, next step is going to be to solve for c, and so we know that its velocity, our velocity is equal to 64 when our time is 0. That's the original time when it hits the sand. So solving for c, I'm going to have 2 times the square root of 64, because that's the same thing as v to the 1/2, is equal to a negative t plus c. Well, my t is 0, so I can put a negative 0 there. So this is going to give me 2 times 8 equals c. This is 16 equals c. So my equation coming from here is 2 square root of v equals a negative t plus 16. All right, next thing we want to do is find out how long it travels. So we want to know what t is equal to when our velocity is equal to 0. So I put my 0 in here, and I get 2 square root of 0 equals negative t plus 16. This becomes a 0 equals negative t plus 16. Add the t to the other side, we get t equals 16 seconds, and we are done. All right, folks, that's it. Thanks for watching. Have a good one.